So our project was build a tank. So this is our final design here. Alrighty, so we have our Arduino board here. We have our battery holder. We have our breadboard. We have our utilizing 4 LED lights, 2 push buttons, and we also have 4 photoresistors here that will be used as light sensors to detect the light intensity. And then here on the back we have our 2 DC motors, and we also have our driver motor there. Okay, so originally our intention was for the robot to have 2 functions. We wanted it to be manually controlled using a PS4 controller that would be connected via Bluetooth. And the second function was to have it follow a specific color of light. It could be red, orange, blue, or green, whatever we wanted it to be, and it needed to follow that color of light. And we will have a sensor letting us know if it had veered off a path or if it was staying on track with the light. But we had to deviate from those 2 functions due to the fact that the components and sensors and things that we were going to use to achieve that, some of them came in on time, some of them came in late, and some of them are still in the process of being shipped. So that we had already started building with the components that came in, and then as we got the shipments that came in later, we kind of were able to kind of install them, but we already had pretty much set switch from our original intentions just for the sake of time. And like I said, some shipments are still in the process of being shipped right now. So the components that did get here on time, we started to build around that. So we had to switch our initial plans and initial goals to something new. So our new function is that the photoresistors here will pick up on a low light intensity and a high light intensity. As the photoresistors pick up on the lower light intensity, the robot will move backwards, and the LED lights will turn on as it's in the motion of moving backwards, just like a real car, real vehicle. As you reverse, the reverse lights come on. And as the photoresistors pick up on a higher light intensity, the robot will then begin to move forward, and the LEDs will cut off. And as I go through the code, you'll kind of see how we incorporated both of those things. So let me share my screen. So here is our code. Okay, so let me kind of go over this real quick. It'll make it easier. So we're utilizing analog A0 through A3 for our 4 photosensors here. And here we have our ohms here, and we're using the male-to-male to connect them to the analog portion of the Arduino. And we're utilizing 2 push buttons here that we'll be using port A to control. So we have them connected to pins 22 and 23. We're using port C to control our LED lights. We have those connected here with our ohm resistors. I meant to say ohm resistor for here. Ohm resistors, and then we have our male-to-males connected them respectively to pins 37, 36, 35, and 34, port C. And then of course, like I said, on the back here, we have our two DC motors. So in order to utilize those, we need to have pins 46 and 45 for motors 1 and motor 0, whichever one we decide will be 0 and 1. And so we have ENA connected to pin 46 and ENB connected to pin 45. And then we have we need to utilize pins 53 and 52 to control the directions of one motor. And then we'll be using pins 51 and 50 to control the direction of our second motor. So our N1 is connected to 53, pin 53. Our N2 is connected to pin 52. Our N3 is connected to pin 51. And our N4 is connected to pin 50. And then we'll be using our batteries here. Okay. These are 18650 lithium ion 3.7 V batteries here. We may need to use more. So I'll get started in the code. Let me share my screen here. Okay, so like I explained before, we're using photoresistors as the light sensors, so those are connected to the analog portion of our Arduino board. So we have those declared as the variables pin 1, pin 2, pin 3, pin 4, and we'll be storing those values as pin 1 value, pin 2 value, pin 3 value, then pin 4 value, and then we'll be totaling those values and setting them to the variable pin total. This portion here will be used to control the dip switch. So one switch will be set to that switch 1 value variable. The other switch push button will be set to the switch 2 value. We have a counter here, duty, to control the speed of the motor. And then, see, the DT will be used as a delay. And then we'll be keeping track of the old switch values here. We have our function prototypes declared here. And like I said before, we'll be utilizing port C, port A, and port B. So all pins in port A will be used as inputs. All pins in port C will be used as inputs as well. Port B pins will be used as outputs, and we'll have here, we enabled our pull-up resistors. We'll have here set our PWM init function here to control the motors, and then we're utilizing the pin mode built-in function of Arduino to set the pins as inputs. We're using the bit masking here to declare the pins of the push buttons. And then, of course, we have our serial again, which controls the speed of communication. So I'll start down here. Analog read function will be used to read the light intensity of each sensor. And then we'll be storing those as the respective variables you see here. And then we'll be adding them up and declaring them as this variable here. This portion sets it as, allows us to print each pin value in the pin total to the serial monitor, and it'll be printing each light intensity that the photoresistors pick up each for every second, the delay there. And this portion right here, lines 138 to 160, is where we'll be controlling the motor. So kind of the logic that we want it to use, we want it to base the speed of and the motion based off the light intensity, low light intensity, high light intensity. So this threshold, we have two threshold values here, 900 and 200, and I'll show you later how we got those values. So the 900 represents the low light intensity. Oh, actually that's 2000. 2000 represents the the higher light intensity. So as the photo resistors pick up anything from 900 below, the robot itself should start to move backwards. It will continuously move backwards. And here we have our bit masking here to control the directions of our motors. And then we have port C using hexadecimal notation to turn on all LEDs. Okay, so this like the simulation of a real car. The vehicle moves backwards, reversing. The reverse light should be on. Same thing we want to happen here. We're calling our function of each specific motor as it relates to the duty value, sending that duty value to the function to set its speed. And here we have our if else statement condition using the high light intensity threshold value 2000. So once it picks up on anything equal to that value or greater, the mechanism or our robot should start to move forward. So we have the bit masking calling pins 52 and 51. So they should start to move in a clockwise direction, moving the robot forward. And up here, this will start to move it in a counterclockwise, the motor's in a counterclockwise direction in order to produce a backwards movement for the robot. And here we're calling the functions again as they relate to the duty, the functions of each motor as they relate to the duty. And here, using the voids to declare each motor, pin 46 and pin 45. 46 will be used as motor 0, setting the duty value to it, and then pin 45 will be motor 1, setting the duty to it as well. And then we have our void PW in it as well. And up here, from line 66, let's see, 65 to 99, this portion here will be used for the 2 push buttons. So I'll try my best to explain this logic. So two push buttons, one will be used to increase the speed and one will be used to decrease the speed. So basically the logic of this, I'll do my best to explain, is we'll have a set range of speed going from negative 255 to positive 255. So it'll, as you press, so it'll start off initially as a duty value, and as you press, continuously press the switch value of 1, which is push value 1, it will increase the duty of the motors. So it will keep track of the initial or the previous or the old duty value. It will take that and it will increment it by 10 as it keeps track of the amount of times that you have pressed push button 1. Similarly here, push button 2, same thing will happen. As you continuously press push button 2, it will begin to decrease that duty value by an increment of 10. It will keep track of the duty value that you're already at, and it will start to decrement it by 10, and it will as you press the push button, it will keep track of how many times that you are pressing it in order to do so. So now I will show you how we've got our threshold values here. Let me set up my USB cord here. And I'll hook this up to our Arduino board. And then here we have our batteries. These are the 18650 lithium ion 3.7 V batteries here. So I'll go ahead and install these. All right. So now, let me run this code. All right, and then I will show you the serial monitor. So as you can see already, you can see that it's printing the pin values. It's printing pin values, pin value 1, each pin value every second. That's what this delay here is doing. Every second it's going to print a new pin value that the photoresistors are the light that the photoresistors are picking up, the intensity of the light that the photoresistors are picking up. It'll start to print that every second. And here, down here, you can see that the pin total is also being displayed as well. So as the pin total is below 900, what will happen is the LEDs will turn on. Let's see, so the LEDs over here will turn on, and the robot will continuously move backwards. So how we got that threshold value is so in order to receive a high light intensity, so to begin, the light source could be a flashlight, it could be a light bulb from a ceiling fan, or it could be the flashlight from your phone here, any phone you have. So what we did to first receive a highlight intensity is I just simply used the flashlight from my phone, turn that on, set it in a very close range here, and as you can see, you look at the pin total in the serial monitor there. As I have it in close range, the photoresistors are able to pick up on that light intensity a lot easier. And since I have it in close range, they're able to pick it up easier. That will result in a higher light intensity. So we decided to use that value of 2000 there for the for the threshold value of the high light intensity. And let's say if I turn it off, in order to produce a low light intensity, all you need to do is simply have your second light source, at a greater distance than you did your the first light source that created that high light intensity. So basically, for the second light source, we're using the ceiling fan light bulbs here, and it's at some greater distance here. I'll say it's about maybe 5 feet, maybe 6. I'll say 6 feet, yeah. 5 or 6 feet, whatever. And I have it here on the robot here on my desk here. So initially, I had it on the ground. It was on the ground, reading. So here it is on the ground, reading that light intensity. You can see here that from this distance, it's picking up on the light, but it's not able, since it's at a greater range, it's not able to pick it up as well as it was when I was using my phone in a closer range. So you can see here the pin values change, and then the pin total change. So as I create a highlight intensity using my phone, here I have it in right here, about say this distance here. The photoresistors will pick up on that light, detect that light, and if that value there is greater than or equal to 2000, the robot will then begin to move forward in this manner here. So if it's here, I have it at some distance here, producing a higher intensity of, say, 2000 or greater. It will begin to move forward following the path of that light, like this here. And that is the function illustration of our Mechatronic device.